Section 3.2, the product and quotient rules. So in this section we're going to look at rules for taking derivatives of functions that are multiplied together or divided. And this will allow us to calculate derivatives for a whole lot more functions than we've seen so far. So far we really only know how to take derivatives of polynomials and e to the x. And the question that we're sort of looking at, why this is interesting, is in the previous section we learned that if we had two functions that were added together and we wanted to take the derivative of those, then all you did was just take the derivative of the first one and the derivative of the second one, and you added them together. It was very obvious in what you would expect. And the first thing we're going to look at is this the same thing for when you have two functions multiplied together? In particular, do you just take the derivative of the first one and the derivative of the second one and then multiply them together? That's what we're going to look at in example 1. So in example 1, we have f of x equals x cubed and g of x equals x squared. We're just going to look at a particular example. If I take the derivative of x cubed, I get 3x squared. If I take the derivative of x squared, I get 2x. And now if we multiply the original functions together, that's x cubed times x squared, that gives us x to the 5th. And if we take the derivative of f of x times g of x, which in this case is x to the 5th, we get 5x to the 4th. All these are just using the power rule. And so the question is, will this give me the same thing as if I take the derivative of f and multiply it by the derivative of g prime of x? Well, let's see. This thing right here we just saw was 5x to the 4th. And f prime of x we found was 3x squared. And g prime of x was 2x. Well, if I multiply those two together, I get 6x cubed. So is 5x to the 4th equal to 6x cubed? No. So it turns out that what we might intuitively think would work with derivatives of two things multiplied together does not work. It fails in this example, and it's going to fail in general. So to get you ready for this next exercise, I want to mention this math game that's played in sort of math competitions or elementary school, like math clubs, things of that sort. The idea is you take these numbers, say 2, 3, 4, and 7, and you're going to try to find some operations, multiplication, subtraction, exponents, and you want to combine these things in such a way with these operations to make an expression that equals 5. And it turns out the answer is yes. If you multiply the 3 times the 7, and then you subtract the 4 raised to the second power, that's 21 minus 16, and it gives you 5. We're now going to try to do a similar thing in exercise 3 with these derivative rules. So in the example above, our f was x cubed, our g was x squared, f prime was 3x squared, and g prime was 2x. And what I want you to do is take these expressions, x cubed, x squared, 3x squared, and 2x, and see if you can figure out the correct value for the derivative of f of x times g of x, which we know should be 5x to the 4th, because we can actually multiply these two first together. So the question is, can you combine x cubed, x squared, 3x squared, and 2x in a certain order and get something equal to 5x to the 4th? And you're just going to be multiplying and adding these in a certain order. So go ahead and pause your video now, try to do that, and then unpause the video when you're done. Okay, so when I look at these things, x cubed, x squared, 3x squared, and 2x, if I'm going to multiply some of them together, I know I'm going to have to multiply some of them together, and I need to get an x to the 4th power. Now if I have x cubed, I would have to multiply that by the 2x in order to get an x to the 4th power. So I think, okay, let me take x cubed and multiply that by 2x. Similarly, if I have this x squared, I need to multiply it by the 3x squared in order to get an x to the 4th. And then I think, well, what happens if I just add those two together? Well, this becomes a 2x to the fourth plus 3x to the fourth, which in fact is equal to 5x to the fourth. So what do we do here? Our x cubed, that was our f, and then we multiplied it by 2x, which was g prime, and then we added to that our x squared, which is g, and we multiplied that by f prime. And it turns out that this is the correct rule for taking the derivative of products. And we'll get to that. That's called the product rule, and we'll get to that in a minute. First, we're going to look at two things divided by each other. In the same way that we checked to see if the rule was correct for products, exactly what we did up here, where we multiplied the functions together first, and then we took the derivative, and then we took the derivatives individually and multiplied them together. We're going to now see if that works for quotients. If I take the one function divided by the other, will it equal the quotient of the derivatives? So pause the video now and try to work on exercise 4. Okay, so remember our f of x here is still x cubed, and our g of x is still x squared. So if I do f of x divided by g of x, that's x cubed divided by x squared, which is just x. And if I take the derivative of f of x over g of x, that's the derivative of x, and by the power rule, that's just going to be 1. Now, f prime of x is equal to 3x squared, and g prime of x is equal to 2x. So if I do f prime of x divided by g prime of x, I get 3x squared divided by 2x. This x will cancel with one of those up above, and I get 3/2 x. And these two are not the same. 1 is not equal to 3/2 x. So our answer here is no. We do not come up with the same value. So this is not a correct rule. And we'll come up with the correct rule later. That's called the quotient rule.